Now let's learn the different text chunking methods that we use when building RAG systems, right? But before we start learning these different chunking methods that are supported by LangChain, let me quickly summarize what we learned in the previous lecture on RAG and why do we need these chunking methods, right? So let's say if you ask an LLM what is the weather today, right? So LLM has a cutoff date on when it was last trained, right? So we are asking a question which is related to today, right? So it goes to internet, that is tools, and searches and retrieves the answer for us, right? And question number 2 is, let's say if you ask any question related to your company specific HR information, right? That is specific to your domain. Then it goes to vector database, processes, and retrieves the answer for us, right? So this is the process of RAG, right? RAG is nothing but a search on your domain specific data, right? And then let's say question number 3 is what is LangChain, right? So this is a general question. For general intelligence, LLM will not use RAG, right? Because it already understands and retrieves the answer for us, right? So depending on your input, you have to choose which one to use, right? And we also learned context window, right? So first of all, why do we need to chunk our input data? Whenever we try to build any generative AI applications, we need to keep the LLM context window in mind, right? We already learned that each LLM has its own context window size. So context window is nothing but your input plus the response, that is output, together total number of tokens. Input tokens plus output tokens all together is nothing but your context window. And we cannot pass the whole input document, right? If the document size is really big, for example, let's assume your input document size is in gigabytes or petabytes, right? And if you try to pass these huge documents which are beyond LLM's context window size, then the LLM cannot process that data, right? So to avoid this LLM context window limitation, what we are trying to do, the easiest option is to divide the input document into chunks, right? So that is the reason we are trying to chunk our input document to avoid the context window limitation, right? Now let's try to learn different chunking methods that we use when we are trying to build a RAG application, right? So let's learn what kinds of chunking methods LangChain supports, right? So text chunking is a crucial pre-processing step in RAG, Retrieval-Augmented Generation systems, where documents are broken down into smaller manageable pieces, right? So we've already seen this creating chunks in our question answer RAG application, right? And we have different chunking methods: character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, and semantic chunking. And we have already seen recursive character text splitter, right, which we have used in our RAG question answering project. So let me quickly show that so you will relate to that. So if you see here, we used recursive character text splitter, which is inside LangChain text splitter, and we have used this and created our chunks, right? So we got the text splitter and then we used split text method to get the chunks. So similar to recursive character text splitter, we have different other chunking methods. So let's learn one by one, right? So what is character based chunking? It splits text into chunks based on a fixed number of characters. That is, divide your whole input data based on characters. For example, 100 characters per chunk. That is, whenever 100 characters completes, then it will chunk there. So if you see here, we have this input text and we have a total of 448 characters. And whenever it completes 100 characters, it will chunk there, right? And it is simple and straightforward approach. It doesn't consider semantic meanings or natural breaks. And what are the advantages? It is easy to implement, right? So wherever it completes 100 characters, just chunk there. And consistent chunk sizes, because all the chunk sizes are just 100 characters. Works with any text format, right? And what are the disadvantages with this character based chunking? may break words and sentences in unnatural places. For example, if you see here, the 100 characters is at off, right? So after off, it is trying to chunk. So machine learning a subset of, right? So it chunked there. So with that, what will happen? It doesn't preserve context or meaning. So it will be hard to preserve the context, and it can create chunks that are hard to understand in isolation. So this is one chunk, and then from AI, again next 100 characters, right? So that is one chunk, right? So because of this character based chunking, it is really hard to preserve the context or meaning, right? And then the next one is word based chunking. So what it is, it divides text into chunks containing a specific number of words. For example, let's take this input text, right? So we have a total of 68 words. And let's say if you're trying to divide 50 words per chunk. So from artificial intelligence until AI. So this highlighted portion is 50 words, right? So we are trying to chunk by number of words. So it preserves word boundaries more natural than character based chunking. In character based chunking, so let's say if it completes 100 characters at O, right? So we will lose the context, right? So at least with word based chunking, it preserves word boundaries and it is more natural than character based chunking. This word based chunking is better than character based chunking. And what are the advantages? It prevents word splitting, right? With the character based chunking, we may end up splitting the words, but at least this will prevent word splitting, and it is more predictable chunk sizes in terms of content, right? And it is better readability than character chunks. And what is the disadvantage of using word based chunking? May still break sentences midway, right? So here if you notice, we have a total of 68 words and we are trying to divide 50 words per chunk. So it chunked midway of this sentence, right? And it doesn't consider natural paragraph breaks, right? So it is not trying to consider all the way till language period, right? So this is the paragraph break, right? So it is not trying to consider till here. It is trying to chunk wherever it completes 50 words, right? And chunk sizes can vary significantly in terms of characters, right? But at least this word based chunking, this is better than character based chunking. Okay. And the next one is sentence based chunking. So what is sentence based chunking? Groups a specific number of sentences together. For example, if you see, this is our input text, right? If you notice here, we have 5 sentences here. And let's say if you're trying to divide 2 sentences per chunk, right? So with sentence based chunking, it uses natural language processing NLP to identify sentence boundaries, and it preserves complete thoughts and ideas, right? So we are not chunking in between the sentence. So at least we will be able to preserve the context. And what is the advantage of using sentence based chunking? It maintains sentence integrity, it preserves natural language flow, so it will be easy to understand, right? And better context preservation, more meaningful for NLP tasks, right? So if you are trying to build a generative application and trying to solve an NLP task, right, then in that case better you use sentence based chunking. But what is the disadvantage of sentence based chunking? Chunk sizes can be very uneven, right? So some sentences can be very long and some sentences can be very short, right? So chunk sizes can be very uneven, and long sentences might create oversized chunks, right? And also it requires reliable sentence boundary detection, right? But at least this sentence based chunking, this is better than both character based chunking and also word based chunking. But this sentence based chunking, this is best used when every sentence in your input document has meaning, right? For example, emails or your client invoices or WhatsApp chat messages, right? We can use these sentence based chunking. So depending on your input, we need to pick the right chunking method. And this sentence based chunking method is best used for small size input documents, right? And the next one is paragraph based chunking. So what is paragraph based chunking? This uses paragraph breaks as natural chunk boundaries, right? For example, let's say this is our input text. If you notice here, we have 3 paragraphs and we are trying to divide every 2 paragraphs into one chunk, right? So it preserves document structure and maintains complete topics or ideas. So each paragraph will have its own meaning, right? So at least we can try to preserve the context, right? What is the advantage of using this paragraph based chunking? It preserves natural document organization and it keeps related content together, maintains author's intended structure, ideal for well formatted documents. For example, let's say if you are using your 10K financial input company report, right? So this is usually, the 10K report is usually in a standard fixed format, right? So each paragraph will have its own meaning and it doesn't need to rely on other paragraphs, right? So first you can try to chunk based on paragraphs and then chunk again based on subtitles or rechunk further, right? So you can use this paragraph based chunking when the input document format is very standard, right? And what are the disadvantages of using paragraph based chunking? It can give highly variable chunk sizes, right? For example, let's say you have an upload button and if user is trying to upload different size of documents, right? Then one paragraph can contain only 1 or 2 lines, or maybe other paragraph can contain hundreds of lines, right? So if the user is uploading different size of documents, then this may not be a good idea, right? So use this paragraph based chunking only if you know the input format of your system, right? And the other disadvantage is it depends on consistent paragraph formatting. And if you know your input document paragraph formatting and if it is consistent, then only you go for paragraph based chunking. And it may not work well with poorly structured text, right? So it has to be in well formatted structure, then only you go for paragraph based chunking, right? And the next chunking method is overlapping chunks. So overlapping chunks creates chunks that share some content with adjacent chunks. For example, let's consider this is our input document text. Let's say if you are trying to chunk till data, right? And then again you are trying to overlap from enables till data in the next chunk, right? So that is overlapping chunking, right? It uses a sliding window approach, right? So this will help maintain context across chunk boundaries. So from artificial intelligence till data we are chunking, and then again from enables till next chunk. So we are trying to overlap the chunks, right? So what is the advantage of overlapping chunks? We will get better context preservation and reduces information loss at chunk boundaries, right? Because we are trying to overlap, and it improves retrieval accuracy, helps with context dependent queries. And what is the disadvantage? Because we are trying to overlap, so that means more tokens, right? So it increases storage requirements and it creates redundant data, right? So first chunk will have this data and second chunk also will have this overlap data, right? So which can create redundant data, and it may require deduplication in search results. So in your search results we may see duplicate results, right? And it is more complex to implement than other chunking methods. And we have already used this overlapping chunking, right? And we generally apply overlapping chunks along with either paragraph or word or sentence chunking, right? And how many overlaps we use? This again is a user defined parameter. So this may or may not work all the time. For example, let's see our code. So if you notice here, we have used overlapping size of 50, right? So this is a user defined parameter. And depending on your input document, you have to pick this parameter by trial and error, right? So this may or may not work for varying input documents, right? So that is one of the disadvantages of using overlapping chunks. And the next one is semantic chunking. So semantic chunking splits text based on semantic patterns or rules, right? So if you notice in our code, we are using this pattern. Whenever you see 2 new lines or 1 new line or period or space, try to chunk here, right? So that is what we are telling. Or semantic chunking uses natural topic boundaries and it considers document structure and content meaning. So with semantic chunking, it maintains logical content grouping, preserves topical coherence, better for knowledge retrieval, more natural for human comprehension. And what are the disadvantages? Complex to implement correctly, and it requires sophisticated pattern recognition, and maybe domain specific, can be computationally intensive. This is one of the most famous chunking method. That is 80 to 90% of the cases we use this semantic chunking because we can try to preserve the context, right? And based on semantic meaning, we are trying to chunk here, right? Whereas in other cases, we are trying to give the chunk size or chunk overlap. We are actually relying on some parameters. But whereas in semantic chunking, we are just relying on a pattern. For example, let's say you have a markdown file, right? Or HTML file as input. In that case, you go for semantic chunking, right? For example, let's say when we are trying to create a markdown file, right? This is the Jupyter notebook. And if you give hash heading 1 and click run, so you can see how did we create this with hash, right? So there is a pattern here. And if I give 2 hash and then give heading 2 and run it, so select the markdown and run. So this is heading 1, this is heading 2, and for heading 3, give 3 hashes, right? And then select the markdown and run. So you can see this is heading 3, right? So we are able to create different headings by using this hash, right? So this is a pattern, right? So in markdown, whenever there is a hash, right, it means a heading, right? So you can just tell in the code, whenever there is a hash, try to chunk. So with this semantic chunking, that is, there is a pattern here. So this is one heading. Under the heading, there will be some content, and second heading, there will be some content, third heading, there will be some content. At least with this pattern, we can preserve the context better, right? So majority of the times we try to use this semantic chunking, and LLM is smart enough to look for these markdowns, right? And it will try to understand the format easily. So before we try to use the input document, we have different packages available that can convert our input text and office documents into markdown, right? So for example, Duckling. So if you see this Duckling website, this is the Git repo. And if you see here, we have the code here, right? To convert individual documents with Python, use convert, for example. So you provide the PDF document and it will try to convert into markdown, right? So either you can use Duckling or you can also use Markitdown, right? So Markitdown is a Python tool for converting files and office documents into markdown, right? So once you convert your input document into markdown, LLM will be able to understand this format very easily, right? So that is why you always try to convert your input document into markdown and then you apply semantic chunking, right? And LangChain also supports Duckling, right? So let me show you that. So this is our official LangChain Duckling documentation, and we have Duckling support from LangChain as well, and it is clearly documented here. You can try to explore more by checking these examples, right? But the objective of Duckling is it tries to parse PDF, docx, PowerPoint or HTML and other formats into a rich unified representation including document layout, tables, etc., making them ready for generative AI workflows like RAG, right? So what we are trying to do, before we use our chunking methods, try to apply Duckling, right? And then it will create a patterns and then you apply semantic chunking. So that's about semantic chunking, right? So we talked about character-based chunking, word-based chunking, sentence-based chunking, paragraph-based chunking, overlapping chunking, and semantic chunking. All right. Thank you.